Hello everyone. Students, in the introductory lecture of differential equations, we shall talk about the basic theory of linear differential equation. And in the discussion of basic theories, first we will talk about the linearity and non-linearity. Look at the examples given here. Here in this example, I have written d square y over dx square plus 2y equal to 0 and dy over dx minus sin x is equal to 0. If you look carefully over these two examples, you will find that in the first equation, the order of differential equation is 2 and the degree is 1. And whenever the degree is 1, then we say that a differential equation is said to be a linear one. And in the second example also, the order is 1 and the degree is also 1. Therefore, this equation is also linear one. Hence, a differential equation is said to be a linear if the unknown function. What about the unknown function? Here this expression y occurring in this equation is said to be an unknown function. If the unknown function and all its derivatives occurring in the equation occurs only in the first degree and are not multiplied together, then we say that a differential equation is said to be a linear. Now look at the second example, third one. Here you see that in this equation the order of the differential equation is 2, but the degree is 4. Therefore, it violates the rule of linearity. Hence, it is a non-linear differential equation because linearity demands that degree of differential equation should be 1. But here it is 4. Therefore, this differential equation is non-linear. So, look at this note, and it's very important. LDE means linear differential equation. A linear differential equation is always of first degree. But every differential equation of first degree need not to be a linear. So students, be very careful. If you look at a differential equation which is of degree 1, then you cannot say directly that it is a linear differential equation. For example, in this equation, here you see that degree is 1 because the power over d square by dx square is 1. Therefore, degree is 1, but you can't say that this is a linear differential equation because here the differential coefficient dy dx are multiplied together and having power 2. So whenever such cases occurs in the linear in any ordinary differential equation, then you say that that equation is not a linear one. So this is all about the linearity and non-linearity concepts of linear differential equations. Next concept of the day is homogeneous and the non-homogeneous linear differential equation. You see here the expression I have written. A naught x nth order derivative of y with respect to x plus a1x n minus 1th order derivative of y with respect to x plus so on anx dy dx plus a nxy is equal to fx. This is the general expression for linear differential equation of order n. First you look at this. This is of degree 1 because the power of d raised to n over dx raised to n is 1, and order n because its nth order derivative is occurring in this differential equation. In this equation a naught, this a naught should not be 0, and other a naught, a1, a2, so on, an along with this capital F must be continuous real valued functions of x only over the interval I. Interval can be any one. So this is the general expression for linear differential equation of degree order n and degree 1. If in this equation this fx is 0, then you say that this LDE is homogeneous. If it is non-zero or any other thing, that is if it is not homogeneous. If it is not homogeneous, then fx should not be 0. So this is all about the homogeneous and non-homogeneous linear differential equation. Third one, linear combination. What do you mean by the linear combination? Let I have n functions f1, f2, so on fn. These are n functions and defined over any interval I, and I am able to find out some constants c1, c2, so on cn, and write the expression for these functions in the following way, that is c1 f1 plus c2 f2 plus so on cn fn. Such an expression is said to be a linear combination of the given expressions of f1, f2, so on fn. For example, I have taken three functions f1, f2 and f3. Now I have multiplied these functions with some constant 2 e raised to x, 3 e raised to 2x, 5 e raised to 5x. You can take any constant over here. But when you multiply these functions with some constant and add together, you will get a linear combination of these functions with c1 is equal to 2 and c2 is equal to 3, c5 is equal to, c3 is equal to 5. So this is all about today's lecture. Students, after this lecture, you must be very clear about the concept of linearity. What is linear differential equation, non-linear differential equations, homogeneous differential equation, non-homogeneous linear differential equation, and the linear combination of the differential equation. Thank you.